Hello guys, so let's continue with where we stopped last time. So basically, we were discussing just the basic idea of object-oriented programming. So why do we need to use object-oriented programming? So today we'll move on to basically we'll just try to understand what is a class and what is an object. So basically, class you can think of it's nothing but sort of a blueprint. The actual technical term which you generally use is programming construct. It is nothing but a programming construct defined by sort of a programmer. Right, it is trying to describe an object. So programming construct is nothing but a blueprint. Right, so you've basically written a blueprint which basically describes what does the object do. So it basically describes the object. Okay, it's nothing but a blueprint. So when you get an object is whenever you instantiate a class. Again, instantiate is again a fairly sort of high technical word, but it's nothing but say you have created a class called car. So you've basically created a car class, right? So you've basically created a car class. So I think, yeah, it does a whole lot of different things, which for now, just for sake of representation sake, I'm just putting it as pass. So you create an object. Say, suppose you create a RR car object. You're just creating this. So this is what instantiation basically means. Instantiation basically means you're just running it. You're just executing the class. Right? So that's what basically instantiation basically means. So yeah, this is what. So class is nothing but a blueprint. Blueprint you would know, right? So blueprint basically describes the object. In this particular case, the object in more detail, right? So when you get an object is whenever you sort of instantiate a class. So whenever you sort of run it, right? Running a class, executing the class. That's a more plain, simpler language. Whenever you just execute or run the class, you get an object. So in Python, how do we actually define classes? Is we use the class keyword. The syntax is use a class keyword followed by space and name of the class, right? So yeah, we'll just look at one very basic example. Maybe after that we can move on to a bit more complexities in object oriented programming. So again, for now, I'm creating a sample car class. So in this I'm actually writing something which is called a dunder method. So what is basically dunder is nothing but a double underscore method. Maybe explanation of that, I think we'll discuss that maybe in a bit more later session. But for now, what the current method which I'm writing is def init. So what basically init is, right? I think by now you know that class is nothing but sort of a blueprint, right? So basically get an object whenever a class is run or instantiated. So init basically is, so whenever you create an object, init will always run. Okay, so init will always get executed no matter whatever this thing you're trying to execute. Maybe after you create the object, maybe you can run your methods, you can run your variables and all of that. So, but whenever you create an object, init will get executed. Okay, that's a basic funda over here. Next is you have your self. What is self keyword? Self keyword basically is self always you use to represent the object. Right? So you can use the same class keyword to create 100 different objects, right? So all of them, there are no sort of relation between them. So basically object one, so any changes you make in object one will not sort of cause problems in object two. Yeah, maybe unless you specifically write it saying make a change over there, but unless you don't explicitly write it, I think there won't be any issues. So that's what self is. Self is basically used to represent the object. So you can use the same class, car class, to create 100 different objects, and all of them would be independent. So that is the role of self. Self basically used to represent whatever object you create. Right? In this particular example, what I'm doing is I'm just using self.name is equal to name. So whatever object I create, whatever name value I give, it'll refer back basically to that object only. So that's what self over here is. Next, I basically have self.car type. Again, this is a very, very simple class. So this is run now when you actually look at it. So we'll just check what is the car class. Okay, so yeah, it's throwing an error because I think you need to supply some keywords which I will not give. So next, I think we'll just create one object. Say I'm creating evoke object, evoke car object. So basically what I just need to self, you need not pass it as an argument because self So whenever you just create whatever variable name, so whatever object name you create, self basically gets assigned to that only. So name, say I write a name, then in car type, say suppose I'll write SUV. Yeah, so whatever arguments are there in init. So if it's sort of a required argument, you're supposed to always pass values to that argument. Okay, that's one other thing. So now we have created a evoke object, right? Which is now, say suppose you want to check what is the name, because self.name is there, right? So whatever name you assign over here gets assigned to the object. So you can just go ahead and run evoke dot, right? So you can see now, right? You can get two variables. So you just run this, you get the name of the vehicle, name of the car, right? And then when you do this, car type. Now basically I can use the same class, right? I'm using the same class to create one more object. Say in this particular case, say I'm creating one more new object. Say this is the object which I'm creating. So you can basically use the same class to create n number of objects. So there would be, so whatever changes you make in one would not affect the other, right? Unless sort of you explicitly state that you want these changes to be made. Unless you explicitly state that, until that case, I think there wouldn't be anything happening, right? So yeah, now I've just created two sample objects. You can create a number of objects. So this is what a basic class is. So let's actually go ahead and create one more class, which basically has different methods. The first example, what we looked at, we actually had only one particular class, right? We just basically had only one class with very, very simple method. We just basically go ahead and create a bit more advanced class. So we're just creating a attribute when number of wheels is 4. Next we'll write, say, init method. So what does the init method basically do is it does self, it does name. Then again, very similar arguments, no new arguments as such. Again, just the same arguments. So we just fill it up with self dot name is equal to name self dot car underscore type is, right. So this is done. So again, say we'll write one method called as describe. Okay, so one method basically we are writing is something just called as describe. Again, since this is I'm just using it to explain the concept, right? I'm not actually increasing the complexity. Again, just a very simple method. So in any method, right, in whatever method you need to write, if you write, so if it's so if you actually need to sort of make some changes to the object, right, you need to pass a self argument. Or if whatever method you write does not have any relation with that of the object created, right, you can just run without self. So basically, what is the idea behind self over here is, so whatever object you create, this basically is a method of that particular object. So that is the main idea of using self over here. In this, basically what I'm just writing is I'm just sort of using it as a print statement. Okay, so is it's an amazing but a bit small, right? So again, this is just for explanation's sake. That's why I think you didn't see. That's why I think you won't see much of complexity over there at least in the code, since it's supposed to be just a small one. Since it's supposed to be very simple, this thing, that's why we don't see much of complexity. Jeff car underscore price. Right. Okay, I think price is a new this thing we need to add in the okay, price. I think that's fine. So since you're just adding it as where itself over there, it will basically get added. So the price of is the price of is approximately whatever be the value. All right. So price of this thing. The price of we just use the price of this thing. So now we need to use a self again because the name is stored in that. Okay, so self.name, self.car type. I think this is nothing but this is you need not self because you're not initializing it over there. So you're passing this as an argument. Which is the difference over here, right? So car itself, y self.car underscore type in the first case, and y in the second case, it's only price, right? So price basically you're not attaching with that of the object. You're sort of passing it as an argument in this function. Right? So we'll look at few examples in this. So say suppose I create an object. So say I create a discovery is equal to car. It's car class name. What is the name? Its name is discovery. Okay, I think I'll stick with evoke. So evoke, then one more argument. So now we have created now you created a object from the car class. And now we'll look at few examples. Now we'll look at not examples. We'll look at few methods. Right, in this particular case, if I run describe, I'm just calling this method so you because this one does returns, right? Amazing vectors. Now say suppose you want to know the car price. Yeah, there is a mismatch because the name I've written a different name. So I just write discovery dot car underscore. You can press tab. Press tab to access this method. Say this is a string, so you just write. I don't know. So this is just right. This is how this will basically access it. So this is what a very basic concept on our classes is. So next we'll look at other ideas of object-oriented programming, something like object inheritance. Inheritance basically is you have one base class. You're sort of deriving whatever methods, whatever variables are there in the base class in another new class. So we basically look at a few examples to basically understand that concept. Thank you guys. We'll again meet in the next session.